Good day to you. I'm welcoming you to my chemistry class. Today, we want to have a look at the topic hydrocarbons. What are hydrocarbons? As it is written on the board, and even according to the way the name is coined, hydrocarbons. Hydro from hydrogen, then carbon. That means hydrocarbons are organic compounds which contain hydrogen and carbon only. So hydrocarbon can only be an organic compound, and it can only contain two elements, carbon and hydrogen. These hydrocarbons can be classified into two. We have aliphatic and we have aromatic hydrocarbons. But for your level, we are treating aliphatic hydrocarbon. Now, when we say aliphatic hydrocarbons, these can also be subdivided into saturated or unsaturated aliphatic hydrocarbon, into cyclic or acyclic hydrocarbon. I don't need to take you through cyclic or acyclic, but just have it in mind that either cyclic or acyclic, which is aliphatic, it can only be saturated or unsaturated. Now, how do we know whether it is saturated aliphatic hydrocarbon or unsaturated aliphatic hydrocarbon? This is determined by the number of covalent bond that is bonding carbon to another carbon. Please get that right. Bond that connects carbon atom to another carbon atom can be 1, can be 2, can be 3. So it is this number of bonds between the carbon atoms that will determine whether it is saturated or unsaturated, as we are going to see in the next note. Now, what are saturated hydrocarbons? Any hydrocarbon compound that has only one covalent bond between the carbon atoms are saturated hydrocarbons. As we can see here, there is only one bond connecting the carbons. One bond. That means there will be another carbon, there may be another carbon like this. And the example of saturated hydrocarbons are alkanes. Alkane is a family of hydrocarbons, saturated hydrocarbon. And the molecular formula for alkane is CnH2n+2. N starts from 1. So if you do the mathematics, when you use 1 to replace N, all true, you arrive at CH4. That means CH4 is the molecular formula for the first member of the alkane. And the name of that member is methane. Some pronounce it as methane. So you can do the mathematics. When N is equal to 2, N equal to 3, you get the molecular formula. To know their names, we are going there in our next class. Unsaturated hydrocarbons. Any hydrocarbon that has either either double bonds or triple bonds between carbon atoms is considered to be unsaturated because of that presence of double bond or triple bond. Now look at this. Though we have single bonds here, but since there is a presence of a double bond, even if it is just one double bond, this has made it unsaturated. And here we have presence of only one triple bond. Others are single bonds. As long as there is presence of this triple bond, it has made the whole of this unsaturated hydrocarbon. Okay? Examples of unsaturated hydrocarbons with two bonds, that is double bonds, are the alkanes. Alkanes. You can see it is not A that is here now, it is E. Alkanes. And the formula is CnH2n. But in this case, N cannot start from 1. N begins from 2. That's why I wrote N is greater than or equals to 2. That means if you want to find the first member of this alkane, then we use N equals to 2, as you can see now, e.g. when N is equals to 2, which will give us the first member of alkane, we arrive at C2H4 because 2 times 2 will be 4. And this C2H4 is the molecular formula for the first member of the alkane. And the name of that compound with C2H4 formula is ethene. Ethene. Examples of unsaturated hydrocarbons with triple bonds between the carbon atoms are the alkynes. Alkynes. You can see that it is Y that is here. So if you notice, this is the letter that is changing the three of them. The first one, alkane, A is here. Second one, alkene, E is here. Third one, alkyne, Y is here now. And the general molecular formula for alkyne is CnH2n minus 2, where N is greater than or equals to 2. That means N cannot be 1. Here, the first member of the alkyne can be found, the molecular formula of that member can be found by using 2 to replace N. And when that is done, we arrive at C2H2, which is ethyne. So that means if I want to write the molecular name, the structure for this one, the structure of this one will be this. Yes. So I'll be explaining this in the next video. How we have single bond here and we have single bond there. But this triple bond between this carbon and this carbon is a sign or signal or the symbol for what? Alkyne. So we call it functional group. Now let's briefly talk about aromatic hydrocarbon. We have only benzene, which is C6H6, and its derivatives as aromatic hydrocarbons. Benzene and its derivatives. Its derivatives means those things, those other compounds that we can form from benzene by the addition, by replacing one hydrogen atom with another atom, such as chlorine, oxygen, alkyl, hydroxyl. We can use any one to replace one of these 6 hydrogen, or one or more rather. It can be one or more than one hydrogen that will be replaced. But whichever one, whatever we get, will be called derivative of benzene. But benzene on its own is the main aromatic hydrocarbon we have, which is this. Now, what are the sources of hydrocarbons? That is where hydrocarbons are produced. Petroleum, coal, and natural gas are sources of hydrocarbons. The coal and natural gas are also called fossil fuels. What do we mean by fossil fuels? Fossil fuels means what the product that are formed from the remains of decayed plants and animals that have died many years ago. So once they have decayed, all these can produce natural gas and coal, and we call them fossil fuels. To round up this class, let's have a look at petroleum, which is a source of one of the sources of hydrocarbons. Petroleum, which is also called crude oil, contains many components, and all these components, when we come out of the petroleum, when the petroleum is refined, and the process of refining petroleum is through the method of fractional distillation, which is one of the method of separating mixture which you are taught when you are in first time year 10. Now, this fractional distillation deals with the boiling points of those components. That means the components with the lowest boiling point will come out first. So this is a table to show the one that will come out first. The ones below 40 degrees Celsius, that's petroleum gases and ether. Kerosene will come out at this within this temperature. Gas oil, petrol will come out within this temperature. That is to show that petrol is, comes out first before kerosene. So let me show the remaining ones up here. Diesel fuel. When you hear diesel, that one will come out within this temperature. So the last one, the one that comes out last, is bitumen and other residues. Bitumen comes out when the temperature is above 500. That means this one will not reach its boiling point until the temperature is above 500 degrees Celsius. So that will be the end of this part of hydrocarbon. This is an introduction to hydrocarbon.